All right, so now we're going to get into some application problems. Whenever we have an application problem that involves stuff like this, it's good to give yourself a visual to draw the problem. So you want to give you can get a grasp as to what's actually happening in the problem. So we have a flagpole. Okay, so I'm going to draw myself a flagpole here. Here's my nice flag waving in the wind. And this flagpole casts a shadow on the ground. So there's a shadow of my flag actually on the ground here. Okay, and it says that this shadow is 12 feet. So I'm going to write that in. And shadows are made based off of an angle of the sun. And so my little sunshine's up here, right? Here's my sunshine. Okay, and that angle that we actually say the sun is at is actually measured with the ground. So this is the ground angle of 64 degrees. Now, the other thing we have to hope for is that when the person installed this flagpole, is that they installed it at a 90-degree angle to the ground. We want it to be perpendicular to the ground. And because we're able to say that that has happened, we can apply our right triangle trig to this. Okay, so I'm going to write out my little reminder here, SOHCAHTOA. And I'm going to say, okay, so what is the piece that I'm missing? They want to know the height of the pole. That's the missing piece. So let's figure out what we have here. So this dotted line here is actually the hypotenuse. That doesn't involve anything. We don't have that, and that's not what we're looking for. What we do have is this 12 feet here, which is the adjacent side to the angle. And we are looking for the h, which happens to be the opposite side to the angle that we have. So we need a ratio here that involves the opposite side as well as the adjacent side. And the only one of these three that does that is tangent. So I'm going to set up my ratio. I'm going to say the tangent of the angle measure that I have is equal to the opposite side. Oh, the opposite side is that h, or whatever variable you put for that. And then it's divided by the adjacent side, and the adjacent side is 12. And now we go through our algebra steps to go ahead and get the variable by itself, to isolate the variable. It's being divided by 12 right now, so I'm going to say let's multiply both sides by 12. So what that tells me then is that 12 times the tangent, and I usually put a little tail on my t for tangent so that I know it's not a plus sign, just in case I'm reading it fast. 64 degrees is equal to my h. Well, that's just a matter of typing it in the calculator now. So I say 12, and this is the same calculator I was using in the last video, so I already know my settings are for degrees. So I only have to do that once when I have the calculator open, okay? So 12 times the tangent, I go under functions and find tangent of 64 degrees. And I get that that side is, it doesn't tell me what to round to up here, so I'm just going to pick, let's say 24.6, and my units are feet. Okay, so that's how an application problem is going to work. If they don't give you a picture, the suggestion is to make your own picture for it. Let's check out some more. There's two things that we have to know what we're referring to. So this is like a definition page for you here. Some problems will talk about the angle of elevation. The angle of elevation. And what you have to think of there is that you are this person standing here with a light bulb over your head, right? An angle of elevation is from your sight line if you have to look up. So if I'm standing here right now and I have a tree in front of me, I would use an angle of elevation to see the top of the tree. I'm even with the bottom part of the tree, but to see the top of the tree, I would use an angle of elevation. An angle of depression is if I'm standing here with a little light bulb on my head on top of my, the lighthouse I have out back, I guess. I'm standing here on my lighthouse and I want to see the boat in the water. Well, if I look straight out horizontally, I won't see it. I'm going to have to actually look down to see that lighthouse. I'm sorry, that boat. So this is my angle of depression because it's going from my horizontal down. If I was going from my horizontal up, that would be an angle of elevation. So you have to know what those two things mean so that when you're faced with a word problem that uses them, you're labeling your diagram correctly. All right, so if you need to copy that down, you can pause here, but I'm going to keep going. So here is our problem that uses that information. So a plane is flying at 33,000 feet. That is his elevation. That's how far off the ground he is. So I'm going to put 33,000 feet over here because that's how high up in the air the plane is. And it says it's approaching his final destination. So I'm guessing that over here is our airport, right? Is where he's going to land. These are my little runway lights, okay? Its angle of depression, so from the pilot's viewpoint down, is 5 degrees. So that's actually up there. It's 5 degrees. How far is the plane from the runway? Well, there's my question. We'll make that an X. The problem is, okay, we measure this height of the airplane perpendicular to the ground. So there's where my right triangle is. But this 5 degrees is not inside my right triangle. So I have to do one of two things. Either I remember that property from geometry that says when two parallel lines are cut by a transversal, the alternate interior angles are equal. I know that just rang some bells there. And this is a parallel line to this, and that diagonal right there is my transversal. So that would tell me that this angle measured down here is the opposite interior. So this is 5 degrees. The other thing I could do is if I have two rays that make 90 degrees, which these do, and this is 5 degrees, I know that I can find the other one by doing 90 minus 5 degrees. So this angle would be 85 degrees. So I can really set up with either one of those angle measures, as long as I know one of them, I can start playing with the different trig ratios now to see which one is going to be easy for me to solve. So I put my SOHCAHTOA. Multiple ways to solve this. All right, so if I'm dealing with this 5 degrees here, the 33,000 feet is the opposite side and X is the adjacent. So opposite and adjacent would tell me I could use tangent. So the tangent of 5 degrees equals 33,000 divided by X. Now, I'm not a big fan of that equation right there because X is in the denominator. I might try to find one that's a little easier for me to solve, maybe one using the 85 degrees. So compared to the 85 degrees, X is the opposite side and 33,000 is the adjacent. That's still tangent, but it's going to reverse things on me. If I do the tangent of 85 degrees, opposite 85 degrees is X. And adjacent to 85 degrees is 33,000. This seems a little bit easier to solve than that one. So that's the one I'm going to choose to do. I'm going to multiply both sides by 33,000. And you could have done the other one. It would have been fine. You could either reciprocate both sides, multiply both sides by X. You should get the same answer. You know I'm lazy, so I try and find the easiest one. 33,000 times the tangent of 85 degrees should equal my X. So then I move to my calculator. 33,000 times the tangent of 85 degrees gets me 377,191.7 feet. Now we could calculate how many miles that is. One of the things that you need to know for the future is that 1 mile equals 5,280 feet. That is one of those conversions that you're expected to remember. And we're going to be using that as well. Okay, so there's my application for my airplane problem. And I think I'll stop this video here, and then what I'll do is the next one we'll do some practice problems. So if you're running out of class time, whenever you get towards the end of class, you have 10 minutes left, make sure you go and do the closure. Okay, but there's always extra practice on here if you need that as well.